5 ohm resistor to a battery, 0.36 amps, 4 ohm resistor when it's connected with parallel to 5, the current increases to 0.485. So originally it's a 5 and you have one current, then when you stick in a 4 that's in parallel, the current goes up. Right, so let's try and draw this as best we can. So the way I'm seeing it is originally it's like this with a 5 ohm, is that right? And you have let me draw it again. Originally you have a battery of some kind. Yeah, yeah. Well, I don't know if there's multiple things inside of it, but anyways, there's some voltage in here we don't know, and there's also a small little resistor in here we don't know, and then we connect it along to a 5 ohm resistor, and the ammeter says what? 0.36 is the current. But if from using our VIR triangle, what is the formula for current? Yes, so V over R equals 0.36. Now the V we don't know. It's the E. We don't know it. But the OR, at least we can kind of do something with that, because we can say that the OR is the total resistance. And what's the total resistance here? 5 plus small r equals 0.36. Now, when you change the 5 to a 6, what happens? So if I was to change this now to a 6, then what changes here? That 5 becomes a 6. That's the only difference. Oh no, and the current increases. So, I can't answer this, can I? No, I can't answer it. I have to let it ring out. I'll just have to call them back later. See, this person said I called them like 2 hours ago, and they said I'll ring you right back. So I can't. It's like calling them at lunch, and they said, yeah, okay, just give me the information, and I'll ring you right back. I'm like, okay.
Like after maybe what, 2 hours?
2 hours ago. They should have called me 2 hours ago. All right. People. Right. So the only difference here is this 5 is now a 6.
Why is it 6?
Because it's replaced with a 6 ohm resistor, isn't it?
No, they're adding.
Yeah, adding it to parallel.
Ah, it's not 6. Sorry, because they add in a 6 in parallel.
No,
A 4 in parallel. Right. So we have 1 over 4 plus 1 over 5 equals 1 over r.
20 over 9.
So what is you have it already?
20 over 9.
I'll double check. .22 is the R.
Yes.
I use 20 over 9.
Okay, fine. So I have 2.22 plus small r equals, what's the current now? 0.485. So basically you have 2 equations with 2 unknowns, right? That's all. Isn't it?
Yeah.
So what I could do here is I could write the first one as E equals 0.36 times 5 plus r, and E equals 0.485 times 2.22 plus r. And then what do I do? Make them equal, equate them, yeah, so I get this is equal to this. Can you find the or here?
Yeah.
Hey, you can't, easy peasy. Let me see. So take that down, and I'll get 0.7422 plus 0.7422 or equals 2.22 plus 4. No,
No.
something went wrong here. Something went very wrong.
The multiplication. That's what meant to be 1.8.
Oh, hang on. That's not 0.7422. Sorry, that should be here. That should be 3.711 here.
What?
I divided by this number
Okay.
and then I multiplied, so I should have here 3.711. So I get 3.711 minus 2.22. I got a kind of a big number. That doesn't feel right.
5.76.
Ah, for goodness sake, I forgot here as well. That should be 0. No, that's sorry. That is or. Sorry.
The 5.76.
Yeah. It just feels very big.
I
But,
got 5.86.
yeah, but I mean, I'm just saying that feels very big. But if that's what it is, that's what it is. Okay. Divided by. Right. So you should be getting something like 5.78 or about this. I just feel like that's extremely big, but whatever. So if I put that back in here, I can get the E. Okay, this voltage seems reasonable. 3.88 volts. Now, what do they want? They want exactly those two things I found.
Yeah.
Yes, Fahad.
You got it on the last one.
Yeah. Got this? So let's have a look here.